Hi everyone, in this video I'll take you through the Skynet imaging assignment. The first thing to do is to pull up a list of Messier objects on Wikipedia. This catalog was put together in the late 1700s by a French astronomer named Charles Messier, and it has lots of awesome stuff in it. Supernova remnants, globular clusters, planetary nebula, things we don't even know what they are yet, but we will as we go through the course. For now, we're just trying to find one that looks cool so that we can image it on Skynet. This second one, this globular cluster in the constellation Aquarius, looks kind of neat, so I think I'm going to try to image that for this assignment. The first thing I need to know is whether or not it's visible right now. You'll recall from the readings that not all constellations are visible at all times of year. Here's a picture of the zodiac. The Earth's orbit around the sun is shown in this inner ring, and in January we're right about here, kind of between December and March, but closer to December. So this is where the Earth is, and this is where Aquarius is. It's on the other side of the sun from the Earth, so that when we can point our telescopes at Aquarius, there is a much brighter star in the way that will obscure our view of any star in this constellation or any globular cluster, as the case may be in this constellation. So we're not going to be able to see anything in Aquarius right now in January. We'll have to pick something else that we can see in the night sky. So when the Earth is turned away from the sun, we can see Gemini and Cancer and Leo and Taurus. Those are where we should be looking for things to image. Now, not all of the objects in this Messier list are in constellations of the zodiac. For example, if I wanted to image this really awesome looking planetary nebula, the Ring Nebula, in the constellation Lyra, Lyra isn't in the zodiac, so I need to find another way to figure out when it's going to be visible. I can do that by just going to Google and typing "when is Lyra visible" into the search box. It tells me that it's pretty much overhead spring through autumn, and that's the best time to image it because we want something that's high in the sky, not close to the horizon. So it's probably not a good idea to image something in Lyra in January. It is visible for a couple hours right before dawn, but it's not going to be very high in the sky as it will be in the summer months. So we're gonna not image our Ring Nebula either. We will stick with something in the constellation Taurus. Let's do this supernova remnant, this Crab Nebula in the constellation Taurus. That is a good target for this time of year. I'll click on the picture, and then I will save this picture on my desktop, save image as Crab Nebula on the desktop. And notice it says you can attribute the author. You always want to attribute the author for any work that is not your own. So I'll go to my file where I'm going to do my imaging assignment. I'll say the Crab Nebula is visible in January. I will put a picture that I just downloaded into my file. So insert picture from file and Crab Nebula. And I will attribute the author as Wikipedia showed me how to do that. So I just copy paste that author attribution right below the image. And then I will go and image it. So I'll start at Skynet Junior Scholars. I'll log in, and then I'll click this Go to Skynet button. Sometimes it takes a while to load, so I clicked it earlier and put it in another tab. This is where you'll end up, and you'll go to My Observatory Optical Observing. That's the first destination. And then you click Add New Observation, and you will type the Messier designation right into the target lookup. So all I'm doing is typing M1 into this keywords thing, and I click Search. it knows the Messier catalog. It'll look up M1. It'll say, oh, you're looking for Messier 1. It knows the right ascension and declination already. And if I scroll down on the page, you can see that many of the telescopes in the network can see it at a high elevation, so very high above the horizon. That's exactly what we want. So here's elevation. We want it to be at least above 30 degrees, preferably higher. Save and choose filters. We haven't learned what filters do yet. So you're just going to pick 3 random filters from one of the categories. You could use generic, you could use SDSS, that's another type of filters. Johnson-Cousins is another type of filters, and so are astrophotography. For this assignment, let's stay away from maximum light, narrowband, and special purpose filters. Just randomly, I'll choose 3 within SDSS. Let's do G prime, R prime, and I prime. Save and continue. And then it will tell me which telescopes have those filters. It says Yerkes has those filters, and it can see my target. So I'll just pick one of the Yerkes telescopes, save and continue. And at this point, it'll ask me how many exposures of what duration I want. And I would like you to put in 3 different exposures of 10 seconds, 3 exposures of 30 seconds, and 3 exposures of 50 seconds. So for each exposure length, you have 3 filters. You're going to have a total of 9 observations. So let's just put 1 for each filter that's 10 seconds. And then I'm going to add 6 more rows. And I will make sure that I have my 3 filters, a set of 3 different filters in each one. So I have I, R, and G for each one. And I have 1 exposure of 30 seconds and 1 exposure of 60 seconds. There's 30 and 60. Okay. So now I'm going to, you only have 1 time account to choose from, and I will save and continue. And then it will summarize the observation for me on the next page, and I will go ahead and submit this observation. And once I've submitted it, it will show up in my optical observations as an active observation. So it has an observation ID listed right here, and I want you to take a screenshot of that observation ID. So right here is my screenshot, and stick that into your file as well. Insert picture from this file, and that way I can look up your observation by its observation ID. And here's my screenshot. So now I have imaged a Messier object using 3 filters and 3 different exposure times. And I have it recorded in my file, the object that I imaged, and also the observation ID, which will allow your instructor, i.e. me, to look it up on Skynet. Second, I want you to image something else. And the something else can be anything you want. It can be in our solar system or beyond. I'm going to choose Betelgeuse, a very bright star that we looked at in the reading as well. And hopefully I'm going to spell this right. And I'll search for it. It knows the star name, it knows the right ascension and declination, and fills it in for me. And I will then see it's nice and high in the sky, save and choose filters, and you'll notice something. Let's just choose a couple of filters. You don't need to choose 3 different ones and play around with exposure times for this second observation. This is kind of just for fun. But you choose your filters, you choose your telescope, and then you'll notice that it won't actually let you expose for more than an upper maximum number of seconds, 0.14 seconds on the G' filter and 0.13 seconds on the R' filter. That's because this is a really bright star and it would damage the camera on the telescope if we exposed it for longer than that. So let's just do one exposure of 0.1 seconds on the G' and one of 0.1 seconds on the R'. Again, we don't need to really, this one's kind of just to image something else, so we don't need to be particular about filters or exposure times. And then I submit my observation and once again screenshot that observation ID so that your instructor, that's me, can look it up on Skynet later. So I'll stick this into my file. I'll say my second target will be Betelgeuse. I don't have to put an image of it, but I do have to insert a screenshot to show what the observation ID is. So here I am finding the screenshot on the desktop, and it's right there. I insert it, and then I am done with my Skynet imaging assignment. Save my file, upload it to Canvas. I will see you in section. Thanks for watching.